Welcome to EDU World Space.
So here in this problem we have to calculate the maximum permissible tension in the cable AB if the absolute value of the moment above the coordinate axis of the force exerted on A by the cable AB must be, that is, mx should be less than or equal to 60 kilonewton meter and my should be less than or equals to 12 kilonewton meter and mz should be less than equals to 8 kilonewton meter. So this is the given condition, and we are also given that the length of the crane boom AO is 25 meter. Now from the figure we can calculate the value of OC. So let us use the Pythagoras theorem to calculate OC. So OC would be equals to under root 25 meter square minus 15 meter square. We have applied the Pythagoras theorem to calculate the distance OC. So it will be equals to 20 meters. Now from the figure we can calculate the coordinates of point A, point B and point C. So the coordinate of point A will be 0, 15, 20, and the coordinate of point B will be 2.5, 0, 20, and the coordinates of point C would be 0, 0, 20. Now let us calculate the position vector OA, OB and OC. So the position vector OA will be equals to 15 I cap plus 20 k cap, and the position vector OB will be equals to 2.5 I cap plus 20 k cap. Similarly, the position vector OC will be equals to 20 k cap. Now the position vector RAB will be equals to position vector ROB minus ROA. So we'll get 2.5 I cap minus 15 j cap. So we have calculated the position vector, AB. Now the magnitude of the position vector AB would be equals to under root 2.5 square plus 15 square. This is minus 15, so minus 15 square. So from here we'll get the value as 15.21 meter. Now let us calculate the force vector in the cable AB, and we're going to denote it with P vector. So P vector would be equals to P, the magnitude of P, times RAB divided by the magnitude of RAB. So we have all the values, we can plug it here. So P as it is, this RAB vector we have 2.5 I cap minus 15 j cap divided by 15.21. So we'll get 0.164399 P I cap plus 0.986339 P j cap, and the unit is in kilonewton. Now the moment MO is basically the cross product of RA vector times the P vector, and we know that a cross product is calculated by determinant. So this is I cap, J cap, K cap, and RA vector we have 0, the coefficient of J was 15 and the coefficient for K cap was 20. Similarly here we have P vector, so the coefficient of I cap is this one, 0.164399, and the coefficient of J vector we have negative it should be negative here. I made a mistake, it should be minus here. So minus 0.9863 9, and the coefficient of k vector k cap we have 0. So from here we'll get the value of m naught as 19.7278 p I cap plus 3.270 p j cap minus 2.4525 p k cap. Now we can easily calculate the value of P from here. Now in the question it was given that mx should be less than 60 kilonewton meter, less than or equal to 60 kilonewton meter. So here mx is this one. From the equation we can say 19.7278 p. It should be less than or equals to 60 kilonewton meter. So from here we'll get the value of P as P should be less than or equals to 3.04 kilonewton. Now next it was given that My should be less than or equals to 12 kilonewton meter. So from here we can say that this is y component of m, that is the moment. So we can say that 3.270 p, it should be less than or equals to 12 kilonewton meter. So from here we'll get the value of P as P should be less than or equals to 3.67 kilonewton. Now next we were given that Mz should be less than or equals to it was given as 8 kilonewton meter. From here we can see the component of Mz is 2.4525 P should be less than or equals to 8. So from here we'll get the value of P as P less than or equals to 3.15 kilonewton meter. So the maximum permissible tension P should be less than or equals to 3.04 kilonewton sorry. We have to take the minimum of these value. So that is P should be equals to 3.04 kilonewton. So this is the required answer for the given problem. So I hope you have understood the problem. Thank you.